This project also start in Quantum Jam and then continue as a term project. Okay, Przemek, please continue.
Okay, so hello everyone, here Przemek and Krzysztof, and we decided to create a game. So basically rather exploit or make some use of Qiskit. So instead of created algorithms, we rather focused on things like checking how effective Qiskit can be, and also to have some fun to check how the gates can affect qubits. And how the game works. So basically, each of two players own a qubit, and the goal is to flip the enemy qubit from state 1 to 0, and to be more precise, to catch it in state 0. So unless one of the players demand a measurement, then he can catch the enemy qubit in state 0, and the same applies for the second player. So they are acting one after another. And to flip the enemy qubit from state 1 to 0, they use quantum gates, which I think should be obvious here. But we also decided to add some auxiliary qubits, so players can use some larger gates and moreover create some entanglement, which we found really funny, because once they entangled their qubits, it came out that, for example, none of the players can score a point until the second player scores a point. So it was some kind of a situation like no win, so it's like lose-lose. And the second thing that we spotted is that using a quantum computer would make this game much more playable. And by saying this, we mean like applying some randomness, because most of the gates, if you apply them to state 0 or 1, so the like very basic states, they very often do nothing, which we realize during testing. So like using a real quantum computer would like add more randomness. So then this lack of precision, especially when it comes to flipping qubits, we think it would be kind of funny. And another thing that we spotted is that as every player tries to demand measurement, the game could change even after demanding the measurement, because we applied a system where the whole circuit, so every single operation made during the game was applied another time. So the results of the measurement could differ between turns, which we find even more funny. But there was some drawbacks, some problems. So first of all, like limited gate choice, but I think it was one of the things that we could improve in the future. Also, like the first player has some kind of advantage, but we think it's kind of natural for this kind of games. And the real problem that we need to deal with is that the game was getting slower and slower after time. And at the very beginning, we tried to use Cirq, but then we switched to Qiskit, and it was Qiskit was finally used in this product. But then we realized we could also try to make this game using Julia language, which is much faster than Python. And another problem with using Python and Qiskit was the dependence on packages, because Qiskit is also dependent on matplotlib, which has changed recently. They had a new version, and it caused some problems with the latest version of our games, because some functions used by QCourse511 use matplotlib, and once matplotlib changed, those functions stopped working. So we realized that those kind of projects should be used like maybe not totally without, but as a low level of usage per whole project of external packages. And also we spotted that we should like improve the interface, but luckily or not, we decided not to do this during this semester, during this project, because then we would have even more problems with matplotlib. And we also spotted that by accident, we created a quantum circuit low-code creator where you just type 1 or 2 letters, and then you just like add another quantum gate to your circuit. And maybe I will show it just for a moment. And I would like to also say that it was our first project, like programming projects. So we need to face some problems with GitLab, but more or less it works. Basically, we delivered a successful working version. And here we can decide whether we would like to play to a certain score or to some number of moves, let's say to a certain score, then like some stop criteria. In this case, it would be like maximum score needed, some auxiliary qubits. So let's say we want 1, and then we start playing. So a card in our game is like any quantum gate. And here we have a list of our initial quantum gates. So let's say I would like to use this CNOT gate. And then I can like either attack the enemy qubit or defend myself. So I will choose to attack the enemy qubit. And then we can see that we have added here a new gate. And the game like goes on and goes on. We can demand measurement, so then the state would collapse and some point could be added if the enemy qubit is cached in state 0. We also had here some visualization of those qubits, but unluckily this matplotlib update caused some problems. So just like summarize, we think that for such kind of games we would need some quantum computers, but like taking into account the power and the stability of those computers, we think that we should rather for now focus on finding some better libraries, maybe like develop something in Julia, which is much faster, and I think its packages and libraries are not so interconnected, which would make programs written in this language like much more stable. And so basically that's all what I wanted to say. So thank you for your attention, and if you have any questions, then we would answer them. We'll be very happy to answer them.
Thank you, Przemek. Any question?
Yes, Laurent from France.
Yes, Laura.
Yeah, okay. So first of all, a comment. It is such a fun and brilliant idea. I just love it. I mean, not only doing a quantum game, but doing a quantum game to learn about quantum gates. It's definitely brilliant. And my question is, did you figure out why it gets slower and slower? Is it because like you add more and more gates to game and then you have to recompute everything?
Yes, so basically our idea was to compute everything from the beginning, to like show also how unpredictable some results can be. And basically, as you said, yes, it was the case that the more gates we added, the slower the game was. So basically, it was this problem that you mentioned, that the more gates we have, the slower it gets. And I spotted that it didn't expand in linear time. And from what I've been talking with the professors from my university, it might be the case that we used Python as it had some problems with communicating with the CPU and some other things. So it was rather like some software problems. But yes, it was a very good point that you made. So thank you for asking.
Yeah, but then comes my second question. Why did you feel you had to recompute from the start? I mean, you're adding gates sequentially. So I assume that if you have already like 12 gates, the result at the end, all the calculation and especially since the start is kind of fixed, why don't you just like store the state of your circuit and then recompute it with just one more gate?
So basically we decided to compute the states only when this measurement is demanded, and it costs some a little speed up, but basically the technique was that after every turn we're just adding another gate. We are not computing everything from the very beginning, but once the measurement is demanded, then we compute everything. But that idea that you said also sounds nice, but for like our assumptions that we made at the very beginning, that we want to like see how the game changes, like you add the gates sequentially, but once you compute everything from the beginning, the results can change. So it caused some really unexpected results, but that's a very good point.
Okay, thanks.
Thank you.
Any other question? I mean, I didn't get exactly, but even the complexity can be exponential, by the way. Then,
yeah.
You know that many games are really MP complete, some are P space complete. Like if you look the whole search space, then it's beyond the capability. Have you considered to use some Unity or I don't know JavaScript? Maybe better visualization. I am sure there can be some quantum simulator already.
Yes, we were trying to find some. We also start to create some advanced Python graphics, but like we didn't have enough time for that, and we like tried to focus more on this backend part of the program, but more or less, once we realized how slow it was, like we decided that the first thing we would like to do is like to switch to another maybe language or some kind of framework. And when it comes to using some quantum simulators, like we didn't try it. Like we also had some problems with logging in. We tried to connect to IBM, but more or less, I think we could do it. But first of all, like we would like to change this software.
Okay. And do you seriously plan to continue?
No, we don't think we would continue. Definitely not in this form. Like it needs to be written from the very beginning. And so and also we would like to focus more on quantum machine learning. So I think we will put this project like aside.
Okay. If there is no further question, I would like to thanks. It was very nice to develop a game also.
Okay, thank you a lot.